Hello popcorns, welcome back to my channel. Today we're going to be looking at acids and alkalis. This falls under chemistry for year 7, 8 and 9. In other countries they could be using 6th grade, 7th grade. In some African countries JSS 1, which means junior secondary school 1, 2 and 3. Okay, so let's go ahead and talk about acids and alkalis. So first of all, the key words that I would mention a lot. Some of the words I will mention a lot are words like acids, okay, and a solution that has a pH of less than 7. In my next video, we'll talk about what we mean by the word pH. But for now, I'm just giving you the keywords and what they mean. And then the word that I would use a lot today for this session is base. So what's a base? A base is a substance that reacts with an acid to form a salt. Okay, so I would use the word acid a lot, I would use the word base a lot. And then the next keyword that I would use a lot today is alkali. I'll use that more towards the end of the session. So it's a soluble base, and I'm going to explain that later, that has a pH greater than 7. Okay. And finally, we will talk about litmus paper. Litmus paper is a paper used to test if a solution is an acid or an alkali. Okay. And then the final thing will be to talk about corrosive substances. So when we say something is corrosive, what does it mean? So corrosive substance is a substance that can react to damage, cause skin burn. Okay, so those are the words that I would use a lot today. Words like litmus paper, acid, alkali, base, and then corrosive. Right, so let's move on quickly to the next page. So on here, I'm going to be talking about what are acids, what are bases. Now, we look at acids, like we use acids a lot in the house. Okay, so for example, many people would have come across vinegar, which you actually put in food as well. You would have come across lemon juice or even lemon. That's an acid. We would have come across, okay, not everyone would have seen a battery acid, but the battery that is in the car that we drive, inside it is an acid, okay, and that's what keeps it moving. And then we've got soda, okay. Sometimes we'll say like Coke, Pepsi, those are soda, and those are also acidic in nature. Now, what do all these have in common? With acid, okay, we'll say that it tastes sour. Now, obviously, we would not taste a battery, a car battery. However, if you've tasted vinegar, you've tasted lemon juice, we know that it tends to have a sour taste. Okay, and we'll talk about the pH value in my next video. However, acids will tend to have a pH that is less than 7. So less than 7. It can have a pH of 0, 1, 2, 3, 4, 5, 6, but anything less than 7, that is acidic. Okay. Now, some acids are edible, and some obviously are not edible, like the battery acid that we have. And these are the three major things that you need to know about an acid. Now, let's take a look at a base. We have a baking soda. Okay, we would normally use that in cooking, so that is quite edible as well, hence the word baking. And then we have ammonia. You're not expected to consume ammonia, but it's a base. Now, what we are most likely familiar with is a soap. So we use that either to have a shower. We have a washing powder that we would normally use in our laundry. All of these are base, right? So a base will most likely be soapy. This is more of a feel. When you feel it, it will most likely be soapy. They tend to have a pH that is greater than 7. Okay? Some are edible and some are not edible, just similar to what we've mentioned about an acid. Now I'm going to go to the next page now and then just note down what are the properties of an acid that we should know. Okay. So, number one, we've already said that acids, okay, we have some of them that are edible. Not all acids are dangerous, right? So some are edible. So we have mentioned lemon, we mentioned soda, so okay. And then the ones that are not edible, we say things like hydrochloric acid, uh, car batteries, or just batteries in general. So I think I would use a battery in general. So try the word battery. Because there are other batteries as well that are just not car batteries. Why am I writing a different letter? Okay, there we go. Right, so batteries. Okay, so for the ones that are edible, we'll tend to say that they taste sour. Edible acids, acidic food will taste sour, except like soda where they'll probably add sugar. Because I know some people are probably thinking, but how about soda? When we have soda, it tastes sweet. Yes, that's because they've added sugar into it, but it's still acidic. Now acids can be corrosive, okay, and we'll talk about corrosive in a bit. And then the next thing, which is really, really important, is the fact that they have pH, okay, less than 7. So that means that if you're told that a substance has pH 0, that is acidic. If you're told it has pH 1, that is acidic. 2, that is acidic. 3, 4, 5, 6. And in fact, in some rare occasions, you would come across questions that would say 6.8. That is still acidic. As long as it is less than 7, it is still acidic. If we say 6.9, it's still acidic. It might just mean that it is weak acid or strong acid, but we're not going to talk about that in this video. It will be in my next video. Okay, so let's move on to base. Let's talk about base. Okay, so we've already looked at base. There are some base that we use every day, right? So if I go back to that slide, we spoke about soap. Okay, so base are normally soapy, right? Um, then most of them are not edible. However, you could come across the edible ones like the baking soda that we mentioned earlier, which obviously you are not consuming that directly, but put in food. Um, we've said that it has a pH that is greater than 7. Okay, so for example, What that means is that you can have pH 7.3 on a rare occasion, okay, 7.3, whatever the case may be, that is still greater than 7, all right? 8, 9, all the way through to 14, okay? That will be a base. Now, in my next video, we will talk about what these numbers, what they mean, okay, and what it can tell you in terms of weak alkali, weak, strong alkali, weak base, strong base. Now, the key thing I want us to remember is that when it comes to a base, right, we can have the one that can easily dissolve to form solution. Now, these ones that can easily dissolve to form solution are called alkali. Most times they tend to put the S at the back, alkalis. And then we have a base that cannot easily dissolve to form solution. Okay, in chemistry, if something can easily dissolve to form a solution, we have a word for it. We will say soluble. Okay, and if it cannot easily dissolve to form a solution, we will say insoluble. Now, if you're then, based on what I've just explained, if you're then asked to define an alkali, you would say alkali are soluble base. So that means then that all alkali, okay, are soluble, but not all base are soluble. Okay, so that's something to think about there. Right, let's move on to the next slide. Okay, so we have spoken about acids, we have spoken about base. Now we know that both of them, it's possible for them to be corrosive. Okay, and then that brings us to what we call hazard symbols. Now, hazard symbols are mainly symbols that you would find on the body of a container, okay, to tell you or to warn you of possible danger, right? Or possible what that content can cause to your skin, to environment. Now, the hazard symbol will tell you exactly what to be wary of, basically. Okay, so these are common hazard symbols that you will come across in your exams, and you're expected to know all of these, at least these 8. There are more, way more than this, but these are the common ones that you come across in the exam. Now, straight away, I can already tell the one that would indicate for acid or alkali. So that would be this one here that says corrosive. Okay, meaning that if it pours on your skin, it can burn your skin, or it can even burn through a material, a substance. For example, I wouldn't want acid to pour on my laptop, right? Because again, it's corrosive. I wouldn't want acid to pour on my skin. It is corrosive. Now, all the other ones that you need to be aware of are your flammable, um, compressed gas, oxidizing, harmful, health hazard. Now, sometimes you will go into a lab and you'll find containers that would say toxic. All right, even at home as well, everyday substances that we use at times. So you could see that would say toxic. You just need to be able to remember the word that each symbol, the word that matches with each symbol. Now, some students, when given this one here, they tend to say flammable. That is not flammable. Now, I know that it looks like it's got a flame, okay, but what you need to pay attention to is this circle here in the middle. It's got a flame, but you've got circle in the middle. So you can use that as your guide to remind you that that is oxidizing. Whilst the one that says flammable does not have a circle in the middle. Okay, it just basically means that the one that says flammable, the one that says oxidizing rather, can easily react with oxygen. Okay, and that's what that means. Whilst the other one can easily burst into flames. So if it doesn't have a circle in the middle, it is flammable. If it has that circle in the middle, it's oxidizing. Okay, so these are our symbols, and then for acids and base, we are looking at corrosive. Okay, so what does corrosive mean? A substance that can react to damage or cause chemical burns on skin. All right, so moving on. Finally, if I were to put acid and alkali in a container, right? If I put acid in one container, alkali in another container, can you tell which one is an acid, which one is an alkali just by looking at the substance in the container? I can definitely tell you that that's a no. Okay, so how then can you tell before making use of that substance? All you need to do is to get a litmus paper. Okay, now remember at the start of the lesson, I said that litmus paper is used to test if a solution is an acid or an alkali. Okay, so it's just a piece of paper. One of it will be red and then one will be blue. Now, if it's an acid, okay, acid turns blue litmus paper to red. Okay, but what happens if I put a red litmus paper in that solution? So my litmus paper is already red and I put it in, the red litmus paper will stay red if it's an acid. Okay, but if it's an alkali or a base, it will turn a red litmus paper to blue. Okay, but then what happens if I put a blue litmus paper inside, so a paper that is already blue, it will stay blue. Okay, students tend to think that there's always a change that would happen. No, it's not every time that a change will happen when you put your litmus paper in. So it depends on the color that you put in. So let's look at this image, for example, right? I have my red litmus paper and I put it in that solution. Okay, putting that red litmus paper in tells me that it turns blue. Okay, if it turns blue, that means it's alkali. So I'm just going to draw an arrow from here to show that it turns blue. But when I put a blue one in, it stayed blue. So in case you get this kind of a question in the exam, you would say it stays blue. Okay. Now on this one, I put a blue litmus paper in and the blue litmus paper turns red. That tells me it's an acid. Okay. So one way to help you remember acid, danger, red, danger. Okay, so one way to help you remember that. Now, if I then put a red litmus paper in, the red litmus paper will stay red. So here I would write turns red, and this one stays red. Because it was red when we started, it will stay red if it's going into an acid. Okay. Now there's something we have not mentioned, which this is just going to be what would lead us into my next video. In here, I have put a red litmus paper in. But when I take a look at my red litmus paper after bringing it out, it stays red. Okay. However, before we conclude that it's an acid, let's check the blue litmus paper that we put in the same solution. It stays blue. Now that's a bit weird. Okay, what has happened there? That's because neutralization has occurred. So we have a combination of an alkali and an acid. So that is a neutral solution. Okay, neutral solution. right? It's not an alkali, it's not a base, it's a combination of an alkali and an acid. It's not an acid either on its own. So when it's neutral, then we expect the pH to be 7. So I'll write that here, pH 7, because it is neutral. This would be pH that could be anything between 0 and 6. And this would be pH anything between 8 and 14. Okay, so that brings us to the end of this lesson, or shall I say video. But before I finish off, let's just talk about what we have covered. So, in summary, I would say we have looked at what an acid is, what an alkali is. Okay. In summary, we have looked at whether an acid is edible or not. So we've said that there are some acids that are edible and some that are not edible. And then we have also spoken about base, okay? And we've looked at how we can have a soluble base, which we'll call alkali, and we can have insoluble base, okay? So, said edible acids have a sour taste, so that's how we can tell with our taste buds. We also have said alkali are soluble base, mentioned that. And we said some acids and alkali are corrosive. So, and hazard symbols can give a warning. Okay. And then the last thing that we then mentioned is how we can use a litmus paper to tell whether the solution you are looking at is an acid or an alkali. So we said an acid turns blue litmus paper. Red. An alkali turns red litmus paper blue. Okay, and that brings us to the end of this session. Thank you, Popcorns, for watching, and for those who have already subscribed, thank you very much. Please subscribe and like the channel. Bye.